Thanks a lot, Steve. And I'll add my thanks to the National Academy for hosting this event and to the organizers for including me as well. It's a real honor to be a part of this really fascinating and important conversation. So I should mention that what I'm going to talk about today stems from some recent work with Kathy Kling, who you just heard from earlier today, as well as Joe Shapiro. And what I wanted to do is to provide a little bit of food for thought concerning a pretty tricky yet really important issue on the economics of water quality policies in the U.S. today. And so Chris just told us that we, there are trillions of dollars of benefits that the ocean provides, and I think that most of us in this room would say that water quality and water resources provide a tremendous amount of services to society, yet we've spent trillions of dollars on water pollution control programs in the U.S. over the last several decades. But then when we as economists try to measure the benefits of these programs, oftentimes we find benefits that are significantly smaller than their costs. And so I think that this can lead us to different conclusions. One of these might be that we might conclude that the benefits are truly smaller than their costs, and thus we should either scale back on efforts or potentially redesign our policies so that those cost-benefit ratios are a little bit better. Or what I'll also argue is that it might potentially be that benefits are just really difficult to measure. And if that's the case, then I think this is kind of a call for more research into this field, both by economists and ecologists, to try to help us design better ways to measure the benefits of water pollution control policies. And so to provide a little bit of context for this figure shows historic spending on water pollution control programs in the US from 1960 up through 2015 and across three broad categories that you'll see here. And so, let's see here, maybe the top one. Yep. So this dark blue area here, this represents spending on municipal wastewater treatment plants in the US. The medium blue is additional spending by private facilities on controlling water pollution in the US, and then the light blue is spending that is primarily targeted non-point sources of water pollution, so things like agricultural and urban runoff. And one of the first things that you might see here, or that might jump out to you, is that we're spending about $10 billion a year in the 1960s, and then shortly after the passage of the Clean Water Act in 1972, the spending skyrockets. It jumps up to about $40 to $50 billion, and what you'll note is that it particularly jumps for spending on municipal wastewater treatment plants and spending by private industrial facilities. So it jumps up to about $40 to $50 billion, and we've remained remained at that level for the last several decades. The last thing I'll point out here on this picture, though, is that when we look at total spending as a share of real GDP by this dashed red line, the spending, again, similar kind of story after the Clean Water Act. It increases substantially up to about 0.7%, but then it's fallen fairly steadily over the last several decades to where we're now almost at pre-Clean Water Act levels today. And so just the sheer magnitude of the spending, the change in the spending over time, as well as the distribution of the spending across categories, raises some really important public policy questions. And so, one, how effective has the spending been, both in terms of on its impact on water quality, and then two, how effective has the spending been in terms of its impact on economic welfare? So for the first question, how effective has this been in terms of its impact on water quality? There's certainly a number of examples that you can point to across the United States where spending and targeting these municipal and industrial sources of water pollution has dramatically improved water quality in the U.S. So one of the classic cases here is the Cuyahoga River catching on fire in 1969. This was featured in a Time article at the time, and is often pointed to as kind of one of the main tipping points for a big environmental movement in the late 1960s, early 1970s. What we see is shortly thereafter the passage of the Clean Water Act, the creation of the Environmental Protection Agency, there was actually no known picture, I believe, of the 1969 fire, but this is a picture of the Cuyahoga, a much larger fire in 1952. And so the Cuyahoga, during the 1950s, 1960s, early 1970s, certainly was not a very pretty river, right? And so this is another picture taken from the 1960s. There was a lot of industrial municipal waste in the river. I find it really interesting, a New York Times article ran back in 2009 in which they were trying to describe kind of the progression of the Cuyahoga River over time. And they start off the article with this story of Mr. Roberts. So it says, the first time Gene Roberts fell into the Cuyahoga River, he worried he might die. I'm guessing it's not from drowning, right? So then it says the year was 1963, and the river was still an open sewer for industrial waste. Walking home, Mr. Roberts smelled so bad that his friends ran to stay upwind from him. So it might just be kids being kids, and saying, hey, you smell, I'm going to run up from you. But, it's a story of saying that at the time, the river was essentially a hazardous waste, right? There was a lot of nasty pollution in there. So we spent a considerable amount of time and effort and money that's been poured into trying to help improve the Cuyahoga River. And my understanding is that it's much different today. And so this is a picture of people recreating on the river. There's some walks along the river that certainly don't look like someone taking their hand and just running it through a bunch of oil on the river itself. And then the New York Times article goes on to state, recently Mr. Roberts returned to the river carrying his fly fishing rod. In 20 minutes, he caught 6 smallmouth bass. It's a miracle, said Mr. Roberts, the river has come back to life. And so this is one example in the U.S. in which, it seems like these efforts have helped improve water quality, at least for this particular river. But I think we can point to other cases across the United States where this is somewhat similar. So one of the things I didn't realize existed until I was preparing this talk was that the EPA commissioned a group of independent photographers in the 1970s to go out and take pictures of the environment, and to take pictures of the environment at the time as this agency was just beginning. And so the National Archives has something like 20,000 of these pictures across the U.S. And so, of course, I had a little bit of freedom to cherry pick some of these pictures, but this was a picture that I saw that showed Staten Island Beach and in 1973. And what I thought was really fascinating about this picture, it says warning danger. Part of it says swimming prohibited, but even just says walking or swimming prohibited. So it seems like at the time, maybe this area was not a place that you wanted to swim. If you go and look at Staten Island's visitor webpage today, what you'll see is, I believe this is the same beach, right, with the same bridge in the background. The things look much different. The beach looks much cleaner. The water looks much nicer. People were swimming in it. There are other examples, many other examples that you can point to. So the caption on this picture says, a small powerboat makes a U-turn on the Potomac just above Mount Vernon in 1973. So to me, this looks like someone just took an eraser and ran it through a bunch of mud, right? This does not look like a river or the Potomac River. Again, if we look for pictures of the Potomac near Mount Vernon today, what we'll see is kind of a much different story. So this is not to say that water quality is necessarily perfect everywhere or has necessarily improved tremendously along all kinds of pollutants, but at least for the pollutants that we targeted with this tremendous amount of funding, it seems that water quality, at least subjectively, has improved. And some recent work that I have with Joe, what we've done is we've also looked objectively, and so we've cleaned and compiled a tremendous amount of data on water quality in the United States, and what we see is that, at least for conventional measures of water pollution, we see a similar kind of story, that water quality has improved since 1972, but was also improving prior to the Clean Water Act as well. So the blue line is just showing you essentially mean effects of dissolved oxygen deficit levels. The red lines are confidence intervals using a bunch of data across the United States. And so this is dissolved oxygen deficit, which is kind of a main type of measure of the health of an aquatic system. If we look at more composite measures, this is the share of waters not fishable. And we see a similar kind of story that at least it looks objectively that water quality is improving over time. And so to answer kind of that first question, it looks like we were dedicated enough to spend a lot of money and a lot of efforts in terms of improving water quality in the U.S. It looks like at least it's bought us improvements where we've spent our money in terms of the conventional measures of water quality in the U.S. However, the story kind of takes a different turn when we as economists try to measure the benefits of these improvements. And it's been kind of a similar story over the last several decades. So Freeman, in 1982, was trying to get a measure of the benefits and costs of the Clean Water Act. And and then following that, other studies have taken place in the 1990s, Carson and Mitchell's study in 1993, and then the US EPA has actually commissioned a study as well, commissioned a study in 2000 to look at this issue as well. Now, you can kind of stretch these benefit cost ratios where one is, at least on the right-hand side of these intervals, where, Sometimes it looks like maybe the Clean Water Act has positive benefit to cost ratios, but for the most part, most researchers have concluded that it's likely that the Clean Water Act is not going to pass a benefit cost ratio, or going forward into the future, these benefit cost ratios are not very supportive of the Clean Water Act. Similar kind of thing happens when we look at studies of non-point source control programs as well. So this is the Conservation Reserve Program. Of course, the CRP provides more than just benefits of improvements in water quality. Where it gets, I guess, a bit more problematic is when we look at benefit cost analyses of effluent limitation guidelines. So I'll have to thank Al McGartland at EPA for pointing out some of these to us. But what this table shows is this is all, as far as I can find, all major rules, effluent limitation rules that have either been implemented or revised since 2000. And one of the things you'll note here is that for 9 out of 12 of these rules, the benefits to costs are substantially below 1. And I mean, it's to a point where they seem to be, at least from an economics perspective, somewhat troubling. So some of these benefit to cost ratios are something like 5%, 7%, 11%. And again, it's a similar kind of story that we're having a hard time as economists finding benefits of these programs to support these, to argue for the implementation and the continuing implementation of these programs. So these are often less than 1. One of the things that I think is important to point out, though, is that it's not just something that necessarily economists are doing. It might be, but when we look at these benefit to cost ratios for air pollution regulations, what we find is that the benefit to cost ratios are much larger. So the EPA's preferred benefit to cost ratio, I believe, is 42-1 for the Clean Air Act. And so I think this leads us to ask the question, are we properly measuring benefits, right? And what can we do to improve this? And how can economists and ecologists work together to try to better improve the tools that we're using to measure the benefits of water pollution control programs? And so I'll highlight just 2 today. One of these tools is integrated assessment models. And then another tool is kind of broadly defined as econometric and statistical approaches to measuring the benefits of water pollution control programs. Thanks, Steve. So integrated assessment models, most of you might hear this and think of climate change. So it's similar concept in water pollution, where the idea is that we want to combine and marry different models across different fields. So we might want to marry a model of hydrology that tells us where water pollution goes and how it is transformed in the environment. But then ultimately, as economists, what we're interested in doing is taking essentially these concentrations of water pollution, see how they impact actual uses of waterways, and then try to place a dollar amount on them. And what I'll argue is that we've done a fairly decent job over the last several decades. A lot of money has been poured into modeling the flow and fate of water pollution, but where it's been really tricky and really tough is trying to go from these concentrations down to putting a price on them. And this is really where I think a lot of future efforts can be done in terms of economists working with ecologists to improve these links. So what the EPA has traditionally used is what's known as a water quality ladder, where we might have some measures of pollution in a stream, a river or stream, and then we might translate that into a water being suitable for being boatable, fishable, or swimmable. Now, this water quality ladder really kind of goes back to the 1980s, even 1970s, in terms of developing this index. And then as economists, what we do is we try to then value changes from boatable to fishable to swimmable. Now, there's certainly more complex ways of trying to connect these links between changes in the environment to changes in value. So this comes from a paper, Bonnie Keeler and others in 2012, where the idea here is that you might have different kinds of pollutants, so nitrogen, phosphorus, sediment, and temperature. They change the characteristics of the aquatic system that we might care about, and then the idea is to try to figure out how to place a value on changes in these characteristics. So those are integrated assessment models. In terms of econometric and statistical approaches, it's a kind of a different approach here to trying to measure the benefits of water quality changes, where the idea might be that we might instead try to focus on a few key parameters in a statistical model. So for instance, in this paper with Joe, what we're interested in is trying to understand how this large federal grants program impacted both water quality as well as housing values. And so one of the main challenges for these econometric statistical approaches is just, in a first step, getting the data to answer these questions. So this picture shows about 15,000 municipal wastewater treatment plants in the U.S. There's about 150,000 water quality monitors across the U.S. This was data on those federal grants that we got from the EPA. And then kind of the challenge that's facing a lot of economists these days in terms of analyzing the impacts of these programs is then thinking about statistical research designs that we can use to have faith in in interpreting our estimates as causal impacts of these programs. So that these are true benefits of these programs. And one that we used in our paper and that we're highlighting in this work is a research design that essentially is taking advantage of a hydrologic network in the U.S. to use upstream monitors as a potential counterfactual for what would have happened to water quality downstream from a wastewater treatment plant in the absence of a grant. So we use this design and we find that through this grants program it costs about $1.5 million per year to make a river mile fishable. And so in terms of thinking about efforts going forward, I think that there is a lot of room for research in these integrated assessment models to improve the way in which we measure the benefits of these programs. There's also a lot of work that can be done in terms of ex post studies of the benefits of these programs. Most of these have been ex ante studies performed by the EPA. And then another just kind of a quick call for future work is that we have national meetings that convene on the economics of climate change and how we can improve our estimates of the social cost of carbon. And what I would argue for, and one thing that Kathy and I have talked a lot about, is that we need a similar kind of framework and similar kind of meetings where we can convene people to really improve the way in which we're thinking about and measuring the social cost of water pollution and the tools that we use to measure the social cost of water pollution. Certainly not to say that all water pollution is better, so I'll leave this with this picture of Lake Erie in 2011, where nutrient pollution is still a major issue in the United States. So, thanks a lot.